So welcome back to another live build of a data warehouse solution. This is the second part of creating this kind of demonstrations. In the first part, we created the Willibald use case based on the German-speaking Datavault user group that we will link you in the description of this video. In this part, we will create something called the Unified Star Schema created by Francesco Puppini together with Bill Inmon. And this is not a theoretical video. We will in the first 10 minutes explain what the Datavault Builder is, but after that you can jump to the second chapter if you already know what the Datavault Builder is about. We will in real time build a unified star schema from scratch, and we will create a report on top of it so you really see how long it takes, how it works, and you can follow this kind of instruction for yourself. So in the first part, let's explain what a Datavault Builder is about. The Datavault Builder is a data warehouse automation tool, and it replaces many other tools like a data modeling tool, ETL tool, a tool to write documentations, scheduler, deployment tools, data profiler. And it works basically by having a business model that we use for start creating our data warehouse. But we talk to the business user, we talk to our IT guys, and together we can create a data model that works for everyone. IT profits that it will be created automatically at the physical layer. Business users profit that they will get faster results. And by having a two-way synchronization between the implementation and the model, they will as well get reliable metadata later on. And you can integrate this metadata as well in the reports. So if they use Power BI, Tableau, Click, whatever reporting tool, you can display this kind of meta information directly in the reporting tool. But it doesn't stop there. So it converts your data model into working code, tables, views, load statements, but it also covers infrastructure automation, deployment automation. It versions your code in Git. It operates your job. There's a scheduler built in. It calculates your master jobs. It documents everything. It generates data lineage. So after modeling, you're in fact done. You have created something which is production ready. So which layers will we be working on today? We will have in the core a data model where we will create a normalized model of our data. Automatically we'll implement it in real time. We will then stage data from a Microsoft SQL Server database and then link it from the stage to our data model by defining the business keys. And yes, this is a sample data set, so it will be a little bit simpler than probably in your real world use case, but to get the ID, it will be sufficient. The next step is to create the output, and here is where the magic happens. Here we will prepare the data automatically in a special format which is optimized for the Unified Star Schema, so we will create the different stages representing different grains of processes or things, and it will be automatically unified, so then in the reporting layer we can just consume the data and we don't need to modify it or manually write any script to build it up in a way that it's optimized for self-service queries. So what will be our main target is? Our main target is to prepare the data that even if we don't know what the questions of the business users are, that they can later on really decide on what they want to query the data about, and they can combine data from different processes in one report. And maybe even if there are different grains like orders and invoices where there can be a one-to-many relation, they can display this kind of information themselves in the reporting tool. How we will do that? I have already set up the infrastructure for my project. It took me about 2 minutes. It's a Docker-based software, so it runs on my Windows desktop, it runs on Linux servers, it runs in the cloud. Then we will do the modeling together. It will generate the code. In parallel, we can look at the data by profiling it. Documentation data lineage will be created automatically. While we're modeling, we will not look at the automated testing, we will just test our outputs. We will not look at deployment. We have different ways of doing it, from simplified deployment to Git flow-based deployments to automated deployment with CI/CD tools. All of that will not be part of this presentation. If you're interested in this, join one of our other webinars. As well, what we will not look too deep into it, but we will use operations to run our jobs. But as our AdventureWorks data doesn't show any data movement, it will be not that interesting that maybe in webinars that we do about bitemporal data loads. High availability is not a topic in here as well, but can be reached as well. Code versioning would happen in Git, not part of this webinar. And we have REST API for all of our functions as well, not part of this demonstration. So why is the Datavault Builder different than other tools? Most automation tool works with a modeling tool against a repository. You click a button and patterns are applied to create your implementation. And this creates a disconnect between what you model and you implement, at least temporal, but sometimes as well people change the implementation because they need to fix something and it doesn't match anymore. And to solve all of this problem for good, we replace the repository here by a real-time connection between the modeling tool and the implementation, and this makes us the first time agile. You will see while I'm modeling, I can test directly if the data holds true to my assumptions. We will see the changes that we do while creating the output. You will get feedback early and you will deliver business value early. And it's two ways. So if I would go and change my technical implementation, it will change the model. This ensures consistency and long-term success. I will not show this in this demonstration as well. If you want to see that, join our other presentations. But to explain it, if I will create a core business concept like an order or here a flight, in real time, the corresponding database table is created, the metadata is attached to it. If I change the metadata or the table, data model changes. So it is always in sync. The second thing is, by the way, we're not doing this here on your production system. You're doing this in your development machine, on your development machine or in your sandbox. And then we have an ITIL compliant path to deploy the stuff between environments. The second thing which is different is we believe that your physical implementation, so the tables used, indexes used, data types used in the database might change over time because database technology evolves. But here we have the data model which abstracts all of that and we can regenerate again and again your physical implementation. And the difference to other tools is we deliver you all the patterns that are maintained by us. That's why we support only 6 databases and not 30. But these 6 databases are maintained over a long period of time. And not only the new patterns is something you receive, but as well the update script. So this means even clients started 2012 with the Datavault Builder can update to the newest version and you still use it. So let's switch now to the Datavault Builder. So in this part, we will create a data vault model. In the second step, we will go to stage our data. In the third step, we will link the stage data with the data model. Fourth part, we will create the output for the Unified Star Schema, and there is where the magic happens. So while we're doing that, data lineage will be generated, operations will be automatically created, the job will be created, all the loads, we can schedule the stuff if we want, documentation is generated, and we can deploy it at the end out of the box. But for the time being, let's start here with business modeling. And that's the recommended way of what we recommend. So as we have like a system about orders, so let's add here so like something like the order header or maybe even the order. And as I know, there will be different kinds of orders, or at least my business user tells me so. So we will create here a sales order hub. But while modeling, I'm not talking about hubs, I'm talking about concepts, because this is a concept in business language. I'm using here clear English words to describe it, and I group it into a subject area, topic, data domain, however you want to call it, that we know that this belongs together with other stuff. So the first thing is the sales order, and we have then the sales order detail. And then we know that there might be like something like a customer, and we will see it will be more complicated than that. But let's just add it and slowly create here like a conceptual model of what we want to generate. And later on, we will then extend it and extend our output. But this is really built for Agile. So it's not the idea that we create here enterprise data model. So we need to sell a product. And there will be maybe a product hierarchy or something like that later. and we maybe want to analyze the product, or we want to analyze sales, or we want to analyze sales order detail. And this is already many different levels of information that we have here. So I don't go on. I just start now thinking about how this stuff could be connected, or the better way is talk to your business users. So sales orders related to one customer, because I assume there will be not different customers for different sales order lines, otherwise there would be different orders. Many sales order detail lines will be linked to a sales order. And here what we see is that we are here at the logical modeling level. So we're not here at the Datavault modeling level, so we ask as well for expected cardinality. It makes the data model much more clearer, and it will automate later on the part if we want to create a unified star schema. And at this level, it will link to the product. Is this correct? I don't know perfectly. It's a long time since I've worked with the AdventureWorks model, but this is how I imagined that my business could work. And the next step is that we stage the data and we compare if the data matches our model, and if not, we will change it. Let's go to the staging area. Let's connect to source system. And AdventureWorks is not that big that I will split it, at least the tables that I want to use for this demo, to split it into smaller bits. If you work with something like SAP, we recommend to group it into logical source system like COFI and MM to have better overview in the tool. But here, we just create now one source system. We test our connection. So you see the Datavault Builder has built-in ETL functionality, so we can connect to external data. All the layers are ELT, but here we can really connect to external data. And let's see, we have a sales schema, that's cool, and the sales order header. I just select all the columns. I could do delta loading later, filtering stuff, subsetting, CDC loading. I skip all of that. I just keep it to the use case that we right now need. So I could have staged the detail table as well. So let's have a look on where we could have here the person schema. And here it becomes interesting, because here we will see that we don't have something called customer. We have something called business entity, and business entity can have different subtypes. So we could think about it, how to do that later. But for the time being, I just load the business entity table. Let's have a look on what we have in the person as well. There's the person, and the person is as well linked to the business entity. So let's start with that. We will see we missed the businesses right now, but that's perfectly fine. That's about agile progressing, adding stuff, testing it, validating it, and later on going on. But what I'm missing here is the product, because I really like the product from production. Good. So let's go now here to the product and start with that. We add a load. And we now need to find a business key. And honestly, in this example, I simplify things a little bit, because I'm working here right now with the product ID, which you could claim this technical ID. We don't know exactly, the business user didn't know. They say they print it sometimes as well on the invoices, so I'm fine with that. But usually I most probably should take the product number and then need to create a bridge with the product ID as a technical key, stuff like that. That's something about Datavault modeling I want to keep out of this discussion, because I want to like to focus on creating the output, and that will work exactly the same for both scenarios. The cool thing is product ID is unique. In a real world use case, it wouldn't be probably. And now the tool can create so-called hub load, so it will load all the keys here into the product hub, and all the satellites, all the columns into the satellite. The satellite will automatically be creating a history, STD type 2 insert only. Additionally, it created a tracking object, which we don't show in the data model, which will keep track if something was deleted in the source system or not. A classical problem that you will realize probably much later in the project, but here it's already captured. As well, the Datavault Builder standardized, so it went back to the staging table. It extended the staging table now for the product already to contain business key and hash key pre-calculation here in the first two columns. It changed the ETL flow that the next time that I will stage this table, they will be loaded, but I don't even need to do that. As soon as I start loading here the object, the tool knows that these calculations are missing. It will add them, load now the business keys to the hub, and a few seconds later, we should see all this information. And the same is true for the satellite. So what is this first step? Or what are the first steps we already do? We created a data model with our first 4 entities or core business concepts. Step 2, we staged the information we need to fill them. Stage 3, we connected the first staging table with our data model by defining the business key. And this now gets repetitive because this is how it works, and this is how you extend your model again and again, how you combine different data sources into the different elements just by defining the business key. Let's go here for the customer, and let's do this really simplified. And I know AdventureWorks is a little bit more complex. We can look at that later and refactor that. But for the time being, let's say that we load everything which is related to the business entity into the customer object, and let's assume this is in fact just a synonym. Good. And I could now as well go and load these elements that I just created manually, but already in the background, my master job is being created, so I can go in here into the job sections, AdventureWorks, start loading my whole job, and it now knows how to parallelize stuff. As soon as stuff is ready and loaded, it will continue into the core as well. This can be parallelized, and as fast as possible, the data is loaded. So we have now the product and the customer, but we haven't created any relations yet. And this makes now things interesting. So let's add here the load for the sales order. Let's test if the sales order ID is unique. Again, as I say, this is example data. Never happens in the real world. Good. And usually I just go the quick way and I just tell the system to put all the attributes into one satellite. I could split them by different means, PII sensitivity or rate of change. I don't do that. Again, I could refactor that later. It doesn't impact how my universal star schema will look like. Let's add here as well the sales order details. And now it gets interesting because in many cases the sales order detail ID wouldn't be unique, but I would need to combine like the sales order ID with the row ID. Here, very boring, it's unique. Let's do that as well. So now we have already loaded the hubs and the satellites, but we haven't created any relations between them. So let's add that. And now I will do, and that's the most complicated part to understand probably when you start working with the Datavault Builder, like the foreign key definition from the sales order detail table to the product table. So I go to the product hub and I say, in the sales order detail table, there is a column called product ID, and this is the foreign key for the product. I check if it's unique. My assumption is it is not, because I assume there will be products sold more than one times. That's a many-to-one relation. It matches my expectation, so that's perfectly fine. This is exactly what I expected. So automatically it doesn't select keys are unique. It doesn't let you create a satellite because we know, or not automatically, because we know that not all the attributes are dependent on the product key. But if there would be some columns like a product name, which are dependent on the product key, because it's a denormalized table you received, you could normalize that out, but I skipped that for the time being. I just say I want to create this relation. Let's add link load here. And that's it. Now we have created the relation from sales order detail to the product ID. And we will see that we will need these kind of relations then to create our unified star schema. Let's do the same here from the sales order detail to the sales order. So we go from the detail, we take the foreign key to the header. Again, I expect this not to be unique, perfectly fine. Let's add this. And I could add the link load. But in that case, I start thinking and say, hey, wait, I believe that this here should be a unit of work. What is a unit of work? Stuff that belongs logically together. There could be longer discussions as well. I skip it here. I say, okay, so let's replace that here. My current implementation. And let's put just one relation between the sales order detail ID to the sales order and to the product as a unit of work. So we group these two things together. And now it looks a little bit like this. So this looks probably more familiar to most of you that are coming from Datavault modeling, that you group your stuff instead of with binary links just connecting two hubs into something representing all the relations. There are small differences to what I have done here to a classical link, but as well, that's for another discussion. Now from sales order to customer, we need to add the relations. So let's go to the sales order table, to the header. Let's look for the customer ID. And the funny thing is here, it's called customer ID. It's not called business entity ID. So might there be a discrepancy between the concepts of the business entity ID and the customer ID? Let's check that later. For the time being, we just check, yes, it's a many-to-one relation. So we get from the orders the client several times. That's perfectly fine. Let's add a hub load and let's keep this binary link here so we have both options in here, and we will see that in the output we can use both of them. Good, so last thing we do here is with our mini model, let's go in here to jobs and let's load all the stuff. And this concludes the first phase of the core. And the idea is really here that we don't create an enterprise data model and then we start implementing, but we have created just a small part. We implemented it and we go on, we will deliver value to the business and then return and extend the model. And this means that in the Datavault Builder, there might be sections of the model which are perfectly finished, some that are just in a logical state but haven't any data loads, and some parts of the data model that are still in the conceptual phase. But it's one model. And you know that it goes down to implementation just in a very, very fluid way. It's not that we need to export, import it, or stuff like that, that we have one tool for modeling, one for implementing stuff. No, it's everything in one process. So let's go to the next step, the dimensional model. So looking at the dimensional model, it's just a name. You can create here flat table output. You can create here turnable from output. You can create data products. It's in fact, you create select a grain, you select the level of denormalization, you select the attributes naming, you need to do the harmonization in here for the column names, but it's really open to you what you want to output. And we will use this today to create a unified star schema. So let's start here maybe with the customer. And for the customer, we will do a SCD type 1 output, as of now information. We could create a full history, but to make it simple in the first version, let's create this just as of now. And in here we have two different satellites. Why is this the case? Because we loaded data from the business entity and we loaded data from the person table. This created two different satellites. So let's have a look on how this looks like. In here we have just the modified day, and in here we have more attributes. Let's add them all. And we already see that we have some clashes. That modified date is appearing both of them. In fact, I'm not caring when the business entity was created. I just want to know when this business entity was registered as person. So let's store that. And let's have a look at the output. We have the business key, FortiHub customer. Business entity ID, in that case, it's the same. Person type and many other attributes and additional contact information. Let's just check if there are really some columns not null. It looks okay. So that's perfectly fine. Our first output. Let's go to the business rules section. We don't want to add any business rules, and I will not add during the whole demonstration any business rules in here. I just publish the data as it is. And right now, people can start accessing this customer view because I published it. Let's go to the data viewer, simulate that. We could now maybe look at the person type. We can do a heat map or tree map, and we see that we have here different short identifiers. What do they mean? I don't know it. That could be then a feedback of the business user. Hey, thank you, but I have no idea what it means. Please, can you resolve that or put a business rule on top of it and clarifying what these abbreviations mean? We could filter that. I don't want to do that. I just want to remove that. Let's look at demographics here. And let's see what this is. No idea. And maybe we could do aggregation by last name if we have any business users with which are more common. Perfectly fine. So let's assume this data looks valid for first step. Let's go and let's create the next interface. The next interface could be something like the product. Let's publish that as well. Just check if there is anything in the product like color that makes sense to look at. And that's interesting. Some products don't have any color, but why not? Good. So we created, why I did create these two first? Because they're simpler. They have no relations. They just will be referenced by the sales order, the customer, and the sales order and the product by the sales order detail, but they don't reference anything. So I don't create a stage for them yet. The next step is let's create the sales order. And now it becomes interesting. So I will now add all the attributes for first version in here. It can be that later on we need to remove some of the attributes because they're at the wrong level, that we maybe want to push them down to the sales order details, stuff like that. But I keep these discussions for the end. And for the time being, I just add them here and that's it. By the way, I will remove the modified date from the different elements because many reporting tools would try to join on them. I can still, I could have renamed them, but I'm just honestly right now a little bit lazy because I need to do a lot of clicking here and I don't want to take too long for that. Good. So what happened now to the sales order? I created an element for the sales order with all the attributes, but I didn't include the relation to the customer. Why not? If I would create a classical snowflake-like architecture in my report, I could have done that, and then I could go from sales order to customer, from customer to customer attributes. But here we will create something called a stage in the Unified Star Schema. So we will create one element, which we then will be using to unify with other stages to create like a bridge, a Puppini bridge in that case, because he was the inventor of it, to link to the different elements with just one link, which is very efficient, very simple, makes it much more clear in the reports, and it has many other benefits. And I will go to that when we go then in direction of the reporting layer. So this is the first element just for the sales order, all the attributes. And now I will create a second element for the sales order. And that will be this stage again as CD type 1. And in the first version, I will include the obvious. And the obvious is the relation to the customer. So everything which is at the coarser grain, I will include here as a reference. It could be that I need to include as well some attributes of the sales order here to the stage, if this is the grain at which we want to aggregate this kind of numbers. I'm not doing that yet. I will test this out, the basic approach, and then come back and then start deciding on one specific element, which kind of elements we move from the sales order base element to the sales order stage, which will then create this Puppini bridge, which will become at the end our unified fact table over all the processes. But let's do step by step. Let's use the agile approach. That's what we do for the time being. We created here sales order, a second element for the output this stage. Let's do the same now for the sales order details. And we create first the base element. And again, the same approach without thinking too much in the first version. And let's create a stage for it. And the stage now becomes much more interesting for this one. Because this one links to, it's at the grain of the sales order detail, but it links to the product and the sales order. So yes, it is obvious that we will include the business key for the product, and we will include the business key for the sales order, but, and this is the interesting part, something new, we will add as well the link directly to the customer. So this means directly from this stage with just one relation, we can go to all the elements that we just created. And that's a crucial part. This is something new for me, and this is really, really cool. Now we have created two stages. Let's go and let's publish everything that we just created. So the sales order element itself. Let's publish here the stage. Oh no, I don't want to publish the stage. I'll tell you in a second why. The sales order detail. And that's it. So now we have two different stages. One just for the sales order as such with one relation, and we have one for the sales order detail with three relations. The problem is if we try to bring this into tools like ClickView and other reporting tools, we would have now two different fact tables. And this would create something called a circular relation, because this links to the same stuff like this one. Honestly, in my mini example, we don't have the problem yet, so it would still work, but it will create a mess. But to make this much, much simpler, more extendable, preventing all of this kind of circular relations, we need to bring this here in a unified way into the report. So let's do that. For that, and now the magic starts, how we automate the Puppini bridge. I create here a pseudo element called the bridge. And in the first step, it will do nothing. It's just a stand-in. Now I go to dimension model again here. I create here a stand-in for my bridge element. This will be just to unifying my different stages. Let's go now to the business rule. And let's create here one for the sales order. So for every stage we want to add to our bridge, in the first step, we create here an element. And we do here a select star from this stage. And we name it. And you see that I did a SQL error, so it gives me an error message. I add the comma, and now we can have a look at it. And we see now here that we have the business key for the hub sales order, for the customer, and for the stage. And what I usually like is, it wouldn't be really necessary technically, but to select that the sales order key is in fact my key defining the grain. And I just realized I haven't written down what Francesco recommended me to call this column. But this will always contain from the different stages the relevant key, so we know what is the grain of this element. In that case, the stage key and the business key for the sales order is the same. So let's do now the same for the sales order detail, and I will explain you in a second why I'm doing that. And to be able to copy and paste, because one of the principles working with the Datavault Builder is that you're a little bit lazy, not in a bad way, in a way of making you more efficient. So I want to just copy and paste my stuff. So let's go here and let's create an element for the sales order detail. And that will be selecting from business rule sales order detail. And I can copy here the logic I have created here already. What did I miss? Column business key for hub bridge does not exist. Business key for hub. Yes. I need to replace that with a star. He's correct. Good. Now let's remove here default output. We don't need that. Now we have the different stages, so we can already test them. And the interesting thing is they have a different number of columns because they have a different number of relations. And they will even be more different later on when we add the attributes at the stages, the measures that we need to add them. But already now you see the differences. And in this small example, they're quite different. And this means that in the sales order, we need to make all these columns null, which exist here, and vice versa if this would exist. But you don't need to do that. The Datavault Builder does that already for you. You just need to say how to combine it. I say these are distinct sets, so I don't want to put any priority for combining the data sets. I just mention that I want to combine them, keep them separate, but use sparsely populated columns for this combined data set. And the output is that you get the bridge that you need. Still, without measures, we will look at that later. But let's go here to our bridge element. And we can take here the stage key. That one should be filled everywhere. We can take the stage. And we see here already that sales order detail is bigger than sales order. Cool. Makes perfectly sense. And if we take something like a table here, and we take in here something like the hub customer, it should always be filled. So this regarding on which stage we look at. So let's look Add the sales order. This one is filled, so this one is perfect. And now there's an interesting point. Why is the business key for hub customer not filled for the sales order detail? Because it should be. So this is what we mean with agile approach. So we create the first output, we test it right away. Let's have a look on if we forgot to load something. For me, it looks good. Still, I could reload the job. But I go already back here to the dimensional model, and we go to the stage for the sales order detail, because here the information was missing. And we see here it's still filled, so it's still, the hub customer is filled here already. If we go in here, it still looks okay. Business key. Here it looks interesting. So I did probably a mistake. I went to the wrong element instead of the stage. Let's fix that. And everything will be automatically fixed downstream. So now if you look at the stage, yes, we get as well the sales order detail stage with the customer in it. If you look at something that is only at the detail level, so if we pull in again both stages, but we take something like the product, we will see for the sales order it is null, because at this grain we don't have any relation or link to the product, but at the sales order detail we do have it. So this is our first output. Let's go and let's create the first report on top of it. So before we go into the reporting layer, let's visualize what we have done. So the first thing is we have created here in the core section the data model. So if we go back here to our Chrome browser, we created the relation of the sales order detail, the product and the customer. And as a next step, we went now back into the staging area and we connected it to our source system, to our SQL Server database. We staged all the tables that we need. In the next step, we went back and connected everything to the core by defining a relation from the stage to the core by defining business keys. And then we started to create interfaces. That's in a module called dimension model, but we can do here whatever we like third normal form, flat tables, data products. And just to visualize what the idea is of what we have done so far, we created for every element an output with all the attributes. We will change that a little bit later. We need to remove the measures then from this object and put them into the bridge, but let's go step by step. So product to product, customer to customer, sales order to sales order detail to sales order detail. Now the next step is we created the stages, and the stages contain the relations of these objects to the different layers. For the sales order stage, it means that it relates only to the customer. We don't have any more relations in there. And for the sales order detail stage, it relates already to the sales order, to the product, and even there is no direct link between the sales order detail and the customer, because in the model we have a relation from sales order detail to sales order, from there to customer. The sales order stage can contain all the three relations. And now, after creating both of the stages, we create a bridge. And this creating of the bridge is a union all of the entries in the sales order stage and the sales order detail stage. That's why we named the records in here with the corresponding stage, so we will recognize them. And as this table has less keys than this one, it creates a sparsely populated bridge table containing the relations for the different stages to the elements they know. If they don't know them, if they have no relation to them, they just will be null, and still we can unify them, and this kind of unioning process is automatically created by the Datavault Builder. Before we go to the Power BI tool, let's see what we see at the database. And what I do here is I take the bridge, I join it to the product, I join it to the sales order detail, group it by product, order by product, and I want to get the sum of the line total. So, pretty simple query. Let's do that, and we see we get different values for every product. Now I switch to Power BI. I select the 5 tables that I want to load. I connect it here. I have everything presented in my access layer that was created by the Datavault Builder. And let's load that. And let's see what happens. By using the right naming, the right data, Power BI should be able to create the report right away. And let's see if this will work. So it looks already very good. We have the bridge. The bridge links to the sales order. It links to the product by the product key. It links to sales order detail by the sales order detail key. The nice thing we see here, the many-to-one relations, very cool. This looks like everything was created the right way. Was it? Let's see. So let's drag in now the information, what we want to see. So we want to see now aggregation, and I took here just the business key of the product just to see that it's really the key, that we have the issue on already, and we have the different products that have been sold. And let's now take from the sales order detail as well the line total. Let's drag it in here. Let's create a sum. And what do we see here? That makes perfectly no sense. It aggregated all our traits somehow together, and that looks really, really weird. And the reason for this is that the measure is not presented at the bridge, so it's not at the fact level, but in another dimension. And now somehow these relations got mixed up. And which tools do exactly what is described in Francesco's book. So I will not go into detail. We will look now how to fix that. And the solution to fix that, even we have seen, it works perfectly fine in SQL. It doesn't in here. The funny thing is, other stuff wouldn't work in SQL and it would work here because the tools behave differently. So let's switch now back to the Datavault Builder, and here at the stage of the sales order detail, we will pull in and put in the line total, because this is a measure and the measures should go into the bridge. So they're aggregated correctly in SQL and in the reporting tools. And we will go into the sales order attributes, and let's remove the line order here. Total sales total. Should go to the right object, and here remove the line total. And I haven't moved other stuff. We would need to think about it if this is as well a measure, because we can maybe not sum the unit price, but we can average it, stuff like that. Or the quantity maybe should go as well there, but I'm just showing it now with one measure. And let's see if this propagates automatically. So if we go in here and restore here, sales order, here nothing changed, that's fine. Let's store that, and we will see that automatically the Datavault Builder realized that it was added here to the base stage. As we use the select star here, it extended it. It changed the generation of the bridge, so we're good to go. If we now switch back to SQL level, we will have an issue because our line total is not anymore in the table sales order detail, but it's now in the bridge. Let's have a look at this. This looks still the same. Now let's go to Power BI. And if we put it just the right way, it looks the same as before. But still, how Power BI queries the stuff is different. So if we go back here to our report, so we have still the business key for the hub product. And if we now go to the bridge and we add the line total in here, it looks already better. And it doesn't look only better, it looks now exactly the same as we have seen that in the query in dbeaver. So let's go back there, compare that. Product 707, 157,000. If we go back here to Power BI, 157, 239. That's a little bit rounded. We have more precision in the database, but in fact, that's just a visualization thing. So these are the main parts that are crucial to the bridge. We can bring in different levels of information by creating different stages and union them, creating a sparsely populated fact table. The second thing is we need to move the measures to the bridge. In fact, creating a fact table. And that is it. If we create this like this, it will work in Power BI and other reporting tools. It will work in SQL, and everybody's happy. And now we slowly can extend it, and we can now say, okay, we could now go and count the number of orders in different countries. Would that work? Yes, it would work because we have the different stages and they are linking to the different stuff. So let's try that. If we want to look now and count customers or orders by customer category, we need to fix first one thing that I missed in the beginning here is to make this relationship filter in both directions, because we will now create a relation not from the bridge to one object, but between two objects linked to the bridge. Let's put this here in both, apply the changes. And let's go now to our view, and let's take now the customer category from the customer, which is the person type. And let's go to the sales order, and we want to count the business key hub sales order. Let's aggregate that by a simple count. And let's see what the numbers are. And without the person type, we have 14,000, and with the IN person type, we have 17,000. And now let's go to the database to see what is happening there. And we will see one basic difference, or a crucial difference between the two things. If I execute this query here in the database, we get much higher numbers. And what is the problem here? SQL denormalizes everything down to the level where you start from, in my case, the bridge. So it will denormalize the order header down to every stage entry for the order header. That's fine. but it will also denormalize the order header down to the order details level, and that's not what we want. So we have here about several times the null, several times the in. If I would go and filter here only on one stage, then it becomes clear. That's perfectly fine. And as well, how we could do that and do this both right in both environments. I could imagine we could introduce a count variable on the stage. Let's test that. So let's go here and in fact, we could try it to counting directly stage, but I don't want to do that. I want to add here a new one as sales order counter. We have done this before in all the reporting tools. And one as sales order detail counter. So let's go back in SQL. It looks okay. Let's remove here the filter. Looks okay again. Now let's go back to Power BI. And instead of counting the hub sales order, let's remove that. Let's refresh the data. And the nice thing is we can just take in the sales order detail counter and we get as well the number of rows. And now we see the numbers that we have seen before in the database query were the sum of these two figures and the sum of these two figures. And here it's pretty simple. It works in Power BI. It works in SQL just by adding the measure to the bridge again. And the measure is here now our counter variable.